Today I will share my research on the application of the differential evolution algorithm in unmanned aerial vehicles platforming. This work has the intersection of the optimization algorithm and aerial robotic, offering new perspective on solving complex navigation challenges. And first, for the background, I delve into the realm of UV. It's an unmanned aerial vehicle. It specified how the negative though challenging environments. The motivation behind this study stems from the critical role UAV plays across various sections, including disaster relief, agriculture, and civilizations. And however, effecting pathfinding remains a significant handle, necessitating advanced solutions. As UAV applications expand, optimizing their pathfinding become paramount to enhance optimization, effectiveness, and safety. This research is divided by the needs to explore alternative algorithm and can offer improvement over training method. My invitation centers on the visual illusions algorithm known for this robustness and simplifies in handling complex optimization problems. I aim to access its ability and performance in UAV plan finding research and compounding into the conversational techniques. And for objects and limitations, this prime object of this is to relevance the effectiveness of the DE algorithm in improving UAV plan finding. By conducting a comparative analysis with existing algorithms, I seek to highlight the advantage of and the potential limitations of the DE in the context. However, it's critical to acknowledge the scope of this study. While I'm aimed to provide the comprehensive evolution, certain limitations exist. For instance, the force will be assumed developments to control variables and ensures repairability. Real-world testing also variables for outside this scope into the logical and the resource constant. And for the structures of the work, is structured to guide my journey is civilizations, and I start with an in-depth relative review, establishing the foundation of UAV plan funding and the DE algorithm current standing. Follow this, I divide into the methodology, delight our approach to simulation and analyze the results, session perspective. My finding compare the D algorithm against traditional platforming methods. Finally, I conclude the discussion on the implications of my research, potential application, and avenue for the function work. And for the next part is for the objective and the structures. And the next is the literature review, the application of the differential evolution. And for the literature review, the application of the differential evolution algorithm of the UVA platforming has emerged as significant areas of research due to the increased complexity of UVA emissions and the dimensions of their operations environments. The D algorithm, recognized for its simply roboticness and effective, present a permission solution to the multi-dimensional optimization challenges inherent in UVA platforming. Store the price of the D Storm and Price from 1997 introduced the algorithm as a versionally tools for global optimization, emphasizing its potential in handle nonlinear, non-differentiable, and multi-noble function with case. Their foundational work lays the groundwork for applying the in various optimization problem and including UVA platform. By divisions, its special conventions propried and to other inventory algorithm. And building on this, the research have explored the adaptation of DE for UVA platform finding, focus on the optimized plans in the presence of statistic and dynamic opti energy effect uh, for planting and coordinate paths planting in complex environments. And these studies highlight DE's flexibility in the integrating with other optimizations techniques and its effectiveness in generating safe, effect, and feasible paths of UVAs. A notable advancement is the kidney guides the algorithm provided by Yu in 2021, which triggers the for multi-objective optimization UVA path planning. This varies enhance the traditional DE algorithm by guiding the search perhaps to the most promising regions in the solution spare effective balance between the conflicting objectives such as path legends and safety. And despite these developments, several issues remain underutilized. The integrations of the with real-time data for dynamic task planning. The algorithm platforms is high constrained environments and the stability of the DE-based solutions of the feet of the UVA are areas needing further exploration. Additionally, the comprehensive analysis of the against new mathematical algorithm in UVA pathfinding and remains limited. And for 1997, the Storm and Price uh, contribute the pioneer contributed by them are considered the gold standard in the study of the algorithm. Their work alongside substantive applications in UVA plant finding underscores the algorithm potential in addressing complex optimization problems. However, the finding of the continuum of evolute with concern studied by the Yu and other pushing and for the DE application in UVA plant forming. And next, for the method, the methodology section of this, focusing on the application of the DE algorithm as UVA plan finding, involve a detailed plan for investigating the research request. This plan includes a section of operational method, data collecting tools, and the approach of data analysis. And first, I will tell about the D algorithm principle. And the essence of the differential evolution algorithm is a multi-objective optimization algorithm which is used to solve the overall optimal solutions in multi-dimensional space. And from the start, it will start from here, and for next it's randomly generate initial population in the research space. Each develop individual reception is a potential solution. And next, for the xi, the responses of the population is the G generation, which xi is the ith individual and G is the current generation. And for next part, the algorithm check whether the determination criteria and met the criteria and can be reaching and the maximum number of the generation, finding a good enough solution, or other customers customized stop conditions. And if it's yes, it will determine to for end of the semester. And if it determines it's not met, continue the following steps. For first is need to mutation operation is performed on the individual and the population, usually by contributing the platform of the different evolutions in the populations to form a new candidate solution. And for next is a crossover. Perform crossover operation with corresponding platforms of the mutated individual to increase the division of the population. And the third part is the selection. Eventually, newly generated individual according the fitness function, usually the object function of the optimized problem, and select the best perform individual to form a new population. And for the new next step is a new generation of population in the create. The generation G is increased by 1. And the algorithm return to the beginning of the cycle and continues executations with updated population. And finally, after the determination criteria is met, the algorithm outputs the optimized solutions and found the current best solutions and ends of the run. And the next is for operational method. The core of this research will analyze a comparative analysis approach where the DE algorithm is performance in UVA pathfinding is benchmarked against traditional platform pathfinding algorithm, and it will involve the algorithm implementations, developing implementations of the DE algorithm and select traditional algorithm, ensuring that each is optimized for the context of UVA platforming. This will involve the coding and the algorithm in a high-level program language, such as Python, and due it to extensive support of mathematical operation and its compatibility with data analysis libraries. And next, for the simulation environments, utilizing the simulation software to create realistic UVA plant finding sources, and this will be designed to test the algorithm under various conditions, including statistics, and dynamic optimized varying trainings and different mission objectives. And tools like MATLAB and Gizmo could be used. And as for the data collection tools, it will hinge on material relative to the UVA plant finding effective, such as path, the length, completion time, energy consumptions, and this ability to navigate around optimize. The data will be collected through the simulation environments, will log these materials for each plant finding training threshold. And for the act as the primary tools for both implementing the plant finding algorithm and collecting performance data. And for tools like Git will be used to manage different versions of the algorithm, ensuring that change the code base can be tracked and analyzed. And for data analysis approach, it will involve statistical method to compare the performance of the DE algorithm against traditional algorithm across the collect materials, and to optimize and to summarize the performance data, the highlight general trend in the algorithm effectiveness, and to determine if the difference in performance matrix between the DE algorithm and the traditional algorithm are statistically significant. And for the expected outcomes, the methodology aims to provide a clear exponential comparisons of the DE algorithm platforming against the traditional plant finding algorithm in UVA scalation by employing the rigorous optimization method, specifically data collect tools and determination data analyzed approach. The research seeks design of the most effective algorithm of UVA platforming. And for next part is the schedule. The implementation schedule is for plans over 8 weeks and ensuring the structure approach to achieve this. And for the first and second week, I will focus on the intensive relevant review to identify the key resources of the algorithm applications in UVA platforming. And for the second and the third and the fourth week, it develops the simulation environment using selected tools such as MATLAB and Python, and implement both the DE and traditional platforming algorithm. This phase includes limitation testing to ensure optimal functionality. And for the next 2 weeks also of the data collecting and preliminary analyze is conduct comprehensively a comprehensive simulation to collect data on the platform of the implement algorithm, begin preliminary analysis to identify trends and potential areas of interest of this deep dive. In the 7th week, we're drafting for the Cs with collect data and intentional analyzing began drafting the thesis. This includes detailing the methodology, presenting a preliminary finding, and discussing the implication within the context of existing in the lecture. And for the 8th week, I will complete the final revision of this thesis in and for the details analysis and discussion enhance the thesis meets all academical standing and guidelines for the prepare for the submission. And for the sources, the section and the use of high quality reputed resources are paramount in the adapting the research with solid theoretical foundation and ensuring the reliability of the finding, the stages of the coursing, and incorporating reference is into the thesis and for next steps. The key database and the journals I will use IE Export and the Science Dictionary. This database will be primarily used to access peer-reviewed articles, conferring the papers and journals focusing on the UVA pathfinding algorithm, with a special emphasis on those discussing the DE algorithm, and also the Google Scholar. This boarding research platform will serve as a special the supplementary resources to identify the additional relevant lecture, and including this and the dictionary, the dissertation that may not be available in this other database. And for next is the score selection. I will use priority with be given to resources that have undergone recent peer review and ensure the reliability and the academic recreatability of the information. And the resources select must be directly related to the DE algorithm application in UVA pathfinding or provide the critical insight into the algorithm performance perhaps to traditional platforming method. And also given the fast-paced development in UVA technologies and algorithm, recent publication within the last 5 years will be preferred to ensure the research relevance and timeliness. And for the authors and the journals work, sourced by leading research in the field and publish the high impact journals will be given repetition to draw from the author's voice and groundbreaking studies. And for next is for resource will be For the incorporation is for the first is the elaboration review. The resource will be uh, meticulously reviewed to the map out and the current stage of the research in UVA plant finding, specifically the use and performance of the DE algorithm. This will include the critical analysis of methodology, finding and gaps in the existing interliteratures. And for reference will be used to justify the close method, particularly the selection of the D algorithm and the design of the simulation environment. And for comparative studies and benchmarks from the literature will be used to context visually in the findings, offering the robust discussion on how the results elegance will or diverge from the existing research. And for the last is the reference management. I will use the software tools, reference management software such as Mendeley and Zero Trust, and will be used to organize and manage the creation effectively, ensures in citations and consistent in the reference list according to the chosen translate styles, and by to those guidelines for resources select and usage, the thesis will be built on a foundation of credible and relevant research, contributing meaningfully to the academic resources for surrounding UVA platforming and the applications of the DE algorithm. And the last part is for the reference I make this presentation used. And that's all. Thank you for your listening.